Thank you very much. Thank you. Thank you. So welcome everybody, good morning. So what have we heard all week? Our house is on fire. The problem is that it's not even a house. It's a rusty old trailer in the middle of the desert with 2 meth cooks inside it. That's a problem, right? That's basically the storyline of Breaking Bad. I don't know how many of you have watched on Netflix. You can see it. And actually, interestingly enough, where's Walter White is actually here. Where's Walter? He heads AV. He's somewhere over here. His name is actually Walter White. That's the head character, the lead character of. So let's give AV a hand at Walter White and his team here. That's done a great job this week. So the question Walter had to me is, because you're going to be talking about this TV series, and I go, well, kind of, but not. So I'm going to change the course here a little bit and kind of tie it to the building industry. So our house is on fire. What do we do with it? We're going to look at Breaking Bad, but we're going to break bad AECOO. We need to change things, as we've heard. How do we make that happen? So I'm going to give you some methods and some secrets and some case studies of what we have done, and I'm going to also ask you to interact with me. So please keep your phones open in case you're bored with what I say, or later on when we're working together, I'm going to be interacting through the phone. Some very simple exercises to break bad. So we want to go from bad to good. That's the goal here. How do we get to good? I've seen a lot of patterns in the industry from many different types of owners, and the patterns are repetitive. It's exactly the same pattern. And this is from 25, 30, actually BIM we started using 25 years ago. Before that we were into databases and 3D and everything, so we've been on this journey for a long time. We want to figure out how to get the owner's mind more closely connected to our projects and our portfolio and the services that we provide and the opportunities that would open up for us. So 25 years ago, we were doing a ton of projects for the U.S. Army Corps of Engineers in the Far East. My father's an architect too. And I got these kind of negotiations going about documents. How many square feet of documents are you going to produce? Can you do it at half size? Can you reduce it so we can reduce the sheet count? Our value was tied to actual physical documents, not the knowledge inside them. Smaller projects, even homes. We went through a series of projects with Japanese home builders of building systems to automate the creation of these homes, taking documents and converting them to data and converting them to building information model. This is from over 20 years ago too. US Coast Guard, exactly same pattern. They have documents as well. They had problems finding things, counting them, and documenting them. Every time you go into a project, the first task is go find things. How big is our building? How many assets do we have? Every single project is that same thing, the same pattern again of finding stuff. So we went through a series of projects with the Coast Guard of documenting and building BIMs of their portfolio and automating the creation of sector command centers, 60 sector command centers that were tied to a database and pumped out BIMs as they changed their requirements in a very short period of time. Homeland Security, the headquarters at St. Elizabeth's, same story there. Find, count, document, work with teams, automate the process of building the requirements of a project so we can communicate to our teams what's needed. This was an aha thing. This is the first large owner, 75 million square feet, that we bumped into that actually had data. It made it easy for us to find the data because it was in a database. So we plugged into their system with 5,000 buildings, 75 million square feet, 120,000 spaces, square footage of rooms, types of rooms, whatever, and plugged it in and started talking to it through machines. And this is on the web too, you can see a lot of this. Then the military health system in VA said, wait a minute, if the California community colleges, who's very resource constrained, can do this with very limited resources, why are we spending millions and millions of dollars on our systems that are broken? So owners want to automate the stuff that can be automated, and we need to figure out how to help make that happen for them. We need to help them find, count, and document. And document can mean a lot of different things, so keep that in mind as I go through this. How many of you remember this? How many of you remember this? You had to go find a phone number in a phone book. You had to go to a phone booth that was tethered to the ground. You had to use coins. It smelled bad. it didn't work a lot of times, and you couldn't communicate. Then this came along. Woo! Right? For us in the industry, this was a game changer because it allowed us to be mobile and work with our teams. This was a game changer, but it was still just a step in the direction that we're going. We still, if we put our numbers in here, our phone numbers, if it held numbers and you had to buy a new phone, you basically threw away your data and had to enter it again in another phone, right? Then this came along. Steve Jobs, 2000, what was it, 8? 10 years? Something like that. This was a game changer for many different reasons. It's a form factor. It's basically a computer in our pocket. But the most important thing is this is a platform. It's a platform to build apps on top of. You don't have to start from scratch to build a new app. You can build on top of that platform and get to apps much more quickly. That's why we're seeing Lyfts and Ubers and Amazon. All those companies that are building things rapidly wasn't possible before because platforms were closed. Now it's easy to find. Not only is it easy to find, our expectation is that we can find stuff no matter what. So when millennials come to our industry and say, what the heck is going on here? Right? We're not servicing what the next generation's already expecting and what we're expecting. So the answer is in front of our noses. Just think in terms of that technology. It's simple to use, very easy to find, hard to find in 84, your seat. Now we do this. We expect to see seats disappear as they're bought, right? Real-time data streaming to us to be able to allow us to make decisions, to reduce risk. AI. How many people are scared of AI? Elon Musk is. But machines are really good at certain things. They're very good at counting. Humans, we can only count a certain amount, right? The complexity of the industry is rapidly increasing, and we've already way past peak performance of being able to count the way we do. Even with the tools we're using today, even with BIM the way it's used, it's not efficient. So if you combine the capability of machines and humans, and we heard this yesterday as well, this is scary, but it also creates opportunities for those that are not in the burning house. You have to get out of that trailer, basically, and there's a way to do it. There are opportunities that are going to come up, new types of value that you can bring to the industry alongside what you're already doing. As long as you're a leader in this, you have to lead and be confident and move forward. So this morning I was practicing my speech a little bit, and I got this from my wife. Can you read it? Happy Valentine's, it's Valentine's Day. Send me some chocolates. I go, oh my God, I'm not going to be home for dinner on Valentine's Day. So, how many have forgotten to do this? Anybody else out there? Okay, so let's take a break. Let's order some chocolates on Amazon. And I'm going to walk you through some things that are happening in Amazon. There's a good chance to look at that. So Amazon, I'm live on the web. Walter White in the back told me not to do things live because it's dangerous, so I'm doing it live. It might fail, but we have crew in the back helping in case things happen. So we're on Amazon, and I'm going to search for some chocolates. Okay, what do we got here? It's Valentine's Day. Hershey's. No, that won't do. Oh, they can get it there today, though. This one's tomorrow. That's no good. Let's see what's available today. Okay, what's available today? Oh, that looks pretty good. Today. How are they going to get that there today? Let's take a look. One enough? How many should I get her? I'm not going to be there. But it's going to get there before me. One of the more interesting things in this Amazon here is, do you see this in the corner on the right side? It says, oops, sorry. I'm trying to navigate and do things live here. It says, have one to sell. What the hell does that mean? Have one to sell. That means if you are a supplier of chocolates, you can build on Amazon's platform and sell to the world if I have a warehouse full of chocolates, with no need for hardware, software, logistics, credit cards, nothing. It's all there. So you're basically building, that's a platform. That's why Amazon is exploding, because they've built a platform to do this. So, okay, I'll go ahead and order, buy now, blah, I'm there. Okay, back to this. So, so what's really going on in the background here? Let's study this, because this is an important message. Amazon, how many of you have heard of anticipatory ordering? Amazon has a patent on that. Okay, what that means is Amazon knows what you're going to order before you order it. They're reading our minds. What's going on out there? AI, this is getting scary and spooky, right? But, for example, Valentine's Day, they already know people are going to order chocolates, so they've moved stuff into their warehouse, and they probably even moved it closer to the bigger warehouses in the cities, and they moved it here. On top of that, they know that my buying patterns from last year, I probably ordered some chocolates, so they say, okay, maybe you're ordering chocolates. And they know that I have things in my wish list as well on Amazon, so they're kind of seeing what I'm thinking of buying, and they're predicting, and they're moving product closer and closer to me. Each one of us, they're moving product closer and closer. They're even talking about putting it in trucks and having it on the street ready to be delivered. Imagine drones in the future. They're moving, logistically, they're moving stuff in real time, massive amounts of product to us. What can we learn from that? How are they doing it? So Jeff Bezos went from being a bookseller in 1998 to being a badass today to sell whatever I want, right? He's not a bookseller, right? He started with books. So what changed? In 1998 and 2000, he looked at his systems that he had. He had very powerful computers that did stuff to sell books, right? Inside monolithic towers, huge applications that they had to keep on adding more functionality to. You couldn't get to the data inside very easily, and you needed to buy more systems to make it happen. He knew that they couldn't scale this. This is where most of our owners and agencies are today. They're stuck in older systems, and this is not going to go away overnight. This still exists, but this was 15 years ago. So what did he say? He put out a memo in 2002. Accounting, marketing, sales, logistics, whatever, all these departments could not share information with each other because they had closed systems, they had information in Access files or Excel files on their desktops. So if marketing wanted something from accounting, you had to do a data dump, a data call, transformation, all that stuff to get data from one system to the next, and it was not real time. So he said, from this day forward, all departments will share and expose their data. They will expose it so other departments within Amazon can read directly from it. No back doors, no direct links, nothing. Expose your data. Number two, expose it in a way that even if we have to expose it to the outside world, it's possible. So if somebody from the outside Amazon wanted to get to that, they wanted to build the infrastructure to allow that ability. Then he said, anybody that doesn't do this will be fired, have a nice day. That was 2002. So marketing could go to data, accounting could go to data, and it looks very similar to the silos that we have today, right? We have systems that don't talk to each other, but the data is still valuable. It's not that it's all bad. If you think in terms of the information, the knowledge is valuable, you can get to this. Once they built that, then they started a whole new line of business. It's called Amazon Web Services. They built a platform of shared services for them to use, and they started licensing it for others, including a lot of the exhibitors next door are using this technology already. And there's other solutions out there. It doesn't have to be Amazon. I'm not pushing it. I don't work for Amazon or anything. Basically, this is something that we need to look at because we can build solutions on top of that, including building industry solutions. So we need to evolve from these silos that we have today, the burning house that we have. The reason it's burning is because a lot of this stuff. We worked with the Department of Defense on a strategic roadmap to analyze their systems, and they know they had this problem. We looked at one system that they have that's a monolith, and every time you want to add a new button, they say, we need a new button that does whatever, calculations, or every button. Guess how much every button added to that application is? Just throw out a number. $500,000. One button, $500,000, taxpayer dollars, every button. Because you have closed systems, you have vendors that are feeding off those closed systems, inside teams that are feeding off of it, and the inefficiency. So it kind of feeds itself. So that's bad. So as an owner, do you know what you own? The owners in the room, do you really know what you own? We bumped into this with the Coast Guard. We actually found buildings that were on a database that did not exist when we went to the site because they had multiple databases of buildings, that this building is there, it's not there. The only way to confirm it is to physically go to the site, the building's not there. There's 4 different databases, one says yes, the other one says no. How do you do anything? Imagine Amazon trying to sell books or anything to us if they didn't have that level of accuracy. So case study, this is the Department of Defense Military Health System and Departments of Veterans Affairs for the space and equipment planning system. So this is a find problem. They have a lot of different types of documents. They communicate in different ways, including digital files, and you still have a hard time finding it. So they brought us on board and said, how can we improve this find and count function? This is from an actual project of finding what the existing building rooms are, what department do we have. It's very time-consuming, very expensive, very inefficient, and not a great way to document and find information. In addition to that, they had requirements of how they want to build new healthcare facilities with a lot of data in them. And it was a document like this. The minute you save a PDF file that says, we want this here, if something changes, that is out of date. And if you have thousands and thousands of pages like this on room data sheets to communicate to design and construction teams, then you're constantly chasing your tail trying to find out what do we want. Imagine again if Amazon sold us products by distributing PDF files and saying, check off the boxes that you want in order. That just doesn't work, right? So their assets, they have a ton of assets that are constantly changing requirements. So what's the best practice for a dental exam room? Is that light is outdated, so our new requirement has to be updated. So their data in the background is constantly being updated for the changes of what goes into a room like this, and then it's distributed out to be built on their portfolio of projects, which combined the DoD and VA have 200 million square feet in their portfolio. We know that there's problems out there, and a lot of it has to do with what I'm talking about. And data like this that's just on a PDF, you know, what type of room, what type of floor finish, how many air changes do you want? It's very difficult to process that. When we came in, they were distributing their requirements on CD, or their standards on CDs. This was 4 years ago, 5 years ago. They knew this was wrong because every time they distributed the CDs, it cost $100,000 to burn the CDs and mail them out. And as soon as you got them, they were outdated, and you waited for the next quarter. So we said, where's the data for these CDs coming from? And they said, the data is coming from a system called the Space and Equipment Planning System. And they had data in there about their standards. And the first thing we told them is put it in a database, expose it so others can read it, and then expose some of that data to the world, make it public. And we had really interesting discussions with the security department about that, because these are standards of how do we build hospitals. Is not secure, doesn't need to be secure, but once you get it into an actual building, yes, it's a different level of security. So it's not an all or nothing. It's not about a free-for-all, share everything you have. It's about how do you actually work with that. So we're going to play a little video here for a few minutes.
To make sure that our nation's veterans are being provided the right health care at the right time and in the right place, VA and the Defense Health Agency have developed a software tool to assist in planning the facilities they require. This software is called SEPS, the Space and Equipment Planning System. When VA determines that a new construction or renovation project is necessary, VA planners work with the medical staff to determine key requirements for the facility. These requirements are entered into SEPS. SEPS then calculates the appropriate net square footage for each new room. A list of all the room names and the required square footages is provided in the program for design. SEPS also provides the preliminary project room contents for each room, which is a list of the equipment and furnishings which belong in each room. These 2 pieces of information from SEPS are exported in an electronic file to be used as the basis for the design of the new construction project. To enhance workflow, VA has developed a process to integrate the SEPS project export file with Building Information Modeling, or BIM. BIM is database software that integrates 3-dimensional graphics and data to create virtual buildings. It is commonly used by architects and constructors as part of the design and construction process. In the integrated SEPS BIM process, the exported SEPS information used to begin the design is imported into BIM, a visual, relationally accurate graphic interface. By moving away from static documents to conveying information in an intelligent 3D modeling format, errors that can occur between the requirements and their conversion to the graphic formats are greatly reduced. This means that all key stakeholders will be able to communicate and manage the project more efficiently and effectively. Here's how the SEPS BIM process works when a design team begins the layout for a new dental clinic. The VA planner, working with the medical staff, defines the requirements for the clinic. The VA planner enters the requirements into SEPS, which calculates the necessary space and equipment to support the delivery of healthcare. The planner then exports these requirements by choosing the BIM Excel export button in SEPS. The design team takes the Excel file and imports it into BIM software. In a matter of minutes, BIM integrates all of the data and visual elements as the basis for the new design, such as this example for a new dental clinic. This dental clinic BIM Excel file downloaded from SEPS has hundreds of pieces of equipment that are now displayed as 3D models. The design team and the VA are assured that the information being used to create the design is now the same as the SEPS export. Once the information is in BIM, the design team can edit, arrange, track, communicate, and report on the space and equipment as needed. The SEPS program for design and the preliminary project room contents can be tracked through the project development. This gives the design team and the VA the ability to audit the work, guiding the design and technical decisions and leading to better outcomes.
Okay, so that's on the web. You can actually watch it on your own. There's a lot of other material as well too. So this is about automating. So first they expose their data, just like Jeff Bezos said. Expose your data, make it accessible, don't distribute it by CDs, then build systems on top of that that can read it and do stuff with it. Engineering tools, BIM tools, whatever, same data, different applications. And automate the creation of the requirements. The reason we started with this project, because it's the very beginning of the VA thinking of building a project, right? Once you have the beginning structure in place, then it can feed all the way through design, construction, and into operations. The opportunity for us as an industry is if we can get into the mind of the owner on the day one of what they're thinking of building to this level of detail, imagine the type of value that you can bring back and say, well, what if you do this? Or what if you automate this? Or what if you use modular design, whatever it might be, modular construction. There's a lot of opportunities there to do that. So let's actually go live again to this as well, too. I'm going to show you this live on the web. You can actually try this out yourself. We're actually going to go through this together later on, but sepstobim.org is the website. 100% public, no login, nothing. That was our recommendation to them. Instructions, the videos there. For the techies out there, there are APIs and RESTful web services at the bottom. What that means is that you can plug your applications into that and suck data into your apps to build applications on top of their data, on top of owners' data. The data in the background is constantly being maintained and updated. So if this morning, if VA says, well, we no longer use that light fixture in a dental exam room, it would disappear from the database and we would not have access to it over here, and the applications and the BIMs and everything would not have it as well too. You can go into the tabs along the top, and it's like a shopping cart. What would you like? You want one of these, and one of these, and you go to the shopping cart, and it's, as I hit that button, it's hitting their database, pulling data out of there, pulling it into the BIM, and going to build a BIM from this. A couple of rooms. They also have other systems that automate that selection. I just manually selected, but they have other systems that say if you have this many patients, this and this, then you need 3 of these and 5 of these in a shopping cart. Here you go with your basket. Now you don't have to manually enter this into other systems, and you can even go all the way into departments and say, okay, I want to actually pull down and see what does the dental, this is a pull down list built on an application outside of the government server that's hitting a government server saying what departments do you have. As soon as I select one of these, it actually goes like dental exam, whatever. I put my email address in here, and it's going to send me a link to go and download this. It's building it on the fly. It's going and grabbing all the data from this morning, from the changes, whatever, putting it together and building a BIM of 500,000 square feet or 1,000,000 square feet or 100,000 square feet, whatever it is, in minutes or seconds, depending on the size of the file. So I'll receive an email from that in a few minutes to do that. So that's automation. And the vision, again, is about taking that automation from the beginning so they can get consistency in their projects so they can push it into the portfolio and the management and then loop it back around. And by opening it up to the industry as a platform, it allows forward-looking vendors and consultants to actually tap into this as well. So the structure is the same as the Amazon concept. Decouple, the first recommendation we made, decouple the data, make it accessible, build a service on top of it, then build apps, your own apps or other industry apps. We predicted as soon as this happened, other vendors would come in and say, here's how our app plugs into that, and that's exactly what happened. Here's Revit, here's SketchUp, this is our system actually, Onuma system, ArchiCAD, Atania, medical equipment database that has more information about what type of chair do you want. So in the VA and DOD's database says, we want a lamp of this type. It doesn't say we want a striker or whatever. It goes and this company actually has a database that says, here's 20 options of that, and they link the IDs and you can start churning through the design process. 3D Warehouse took all the objects that were there and created a version of it on 3D Warehouse with the naming that the VA and DOD used. Same thing with BIM Object. And then TriWG is a supplier that says, hey, we sell products. Can we align our product IDs with this owner's ID? It's a very simple database, actually. It's just IDs, 1 through, like the chocolates. Chocolate 1, chocolate 2, chocolate 3. Here's stuff that we have, the type of products that we have that align with this owner's database. And it had to be simple. There's simple applications, too, to get to the data. You don't have to be a techie or a BIM expert to get to the information. Then the consultants and the contractors out there started looking at this, and this is one example I could share from one group that says, hey, we're architects and engineers, and we can build on top of this. So Sherlock, Smith, and Adams is using this process and taking what used to take, they said, weeks to convert data from PDFs or Excel files into BIM and doing it in seconds or minutes, literally. Just boom, it goes in, and there's zero errors on that first import because the data matches. So it's really about the platform and about modularity and being able to plug and play different systems in. So if one app goes away and you plug another app and it's using the same data, it's a plug and play system that basically is what Amazon Web Services and others are doing. And that simplicity of people don't have any more tolerance to spend weeks and weeks learning how to use apps anymore. We pick up an app and we expect to use it on the fly, right? That's the kind of goal we should have. If it's simple apps with data that's accessible, then it makes it easier to use. Others, through the National Institute of Building Sciences, another project we're working through NIBS on for the Department of State, Bureau of Overseas Operations. They looked at what DOD and VA were doing, and they also want the same thing: improved coordination, shared data for the life cycle, improved efficiencies, and supporting projects and portfolio. And we can't share the details of this project yet, but hopefully soon after it's get more mature, we'll be able to share. So the result really is that first slide that I showed you. Imagine an owner's database or an owner's mind, what they're thinking of doing, making it accessible to the industry, and us being able to plug into that and use it for projects. Use it for capital projects, whatever. You start plugging into that and the value streams through. And that piece in the middle is who we all are. You can't, machines alone can't do this. You have to understand the industry. And that's one thing I learned when we started on this journey is 25 years ago when we were doing BIM, if we brought on just technology, computer scientists that did not understand the industry, it's very difficult to communicate to them what you want to build. But knowing how the industry works, that's basically, you are building software. And we're all heading towards that. Every single one of us can be, quote unquote, a software company because we're dealing with knowledge and information in the right format is software. It's basically an application. So BIMStorm. How many of you have heard of BIMStorm? A few of you, okay. This is the 10th year, and basically BIMStorm started as a research and development, internal project for us, research and development. We were trying to test these different connections, but we were having problems finding others in the industry that were like-minded. So we started this, it's an online workshop, and we've had thousands of participants from around the world saying, well, here's an app that we have that can plug into this. A lot of this testing that I showed with VA actually originated here. How can we move data from databases into projects, and then what can happen with teams? What if you go through the whole design and construction process? So we're simulating, it's a digital twin, maybe some of you heard that concept here, a digital twin of buildings and data going through the life cycle. And we kind of played off the Woodstock theme, is that, okay, anybody can come and play in the mud and try things out, and you learn, basically. You learn what's coming up. It was a 24-hour, our first event was actually 24 hours in Los Angeles, called BIMStorm Los Angeles, but we had participants from around the world, this is 10 years ago, plugging in through the internet and saying, here's our capability, and we're working with teams to design, it was a whole city actually, we had I don't know, about 100 million square feet or so of buildings of different levels. Obviously, we're not going to complete it, but we went through a lot of the stages all the way really rapidly. Our latest one is called BIMStorm Planes, Trains, and Automobiles, and it's, we're working with data that San Jose Airport actually gave us access to, all of their plan files and other information. We converted it into an online format, and then we worked with aviation experts, architects and engineers and planners that knew how, I'm not an aviation expert, but we worked with them to say, okay, how do you plan an airport? What are the kit of parts that you need for an airport? And planes are obviously a big driver. If you have a 777 or 787 or a smaller plane, that dictates how much passengers you can get into a terminal, and that drives into the need for space to support that plane. So it's a whole system, and every type of building has a little different dynamic, but if you take the word airport out of here and put hospital, it's exactly the same thing that we talked about with VA. So we built this, and this is actually available online. You can try this out yourself. And we had teams inside meeting rooms and around the world actually interacting and building a 700,000 square foot terminal. We went through this whole simulation. That was actually Mark Giuliani and Associates in Alexandria, Virginia, aviation design architects that we worked with on that particular meeting. And the aircraft driving into space was one of the themes. We also had people that were not computer savvy, but that's still valuable. We're not saying everybody has to be a techie geek. There's a lot of knowledge that we all have, as long as we're tied in and we collaborate with others that can help move that into tools like this. So one of the exercises would put 2 new gates in. Another one was build 700,000 square foot terminal. These were actual scenarios that were coming from San Jose Airport from their master planning studies. They're planning on building 10 new gates there. Then we said, what happens if we look online, that airline schedule that I talked about earlier? There's data coming about flights, right? You can basically pull these off the web. We pulled them off the web, real data from San Jose, and pushed them into the model. So this is a BIM reading scheduling data to simulate overcrowding in the morning and afternoon at certain gate areas, an hour-by-hour study. This all works because it's real time. When you start getting real-time data, just like you can reserve that seat on the plane, you can see which terminal is crowded. It's the same technology. It's basically push data, change colors. Red is bad, that type of thing. Or in this case, I don't think it's bad here. It's basically 2 different types of uses. So we had planes coming in, and we were simulating, here comes an actual flight from overseas coming into this gate. What's it going to look like? What options do we have? You can start iterating and running through scenarios and putting them in front of experts that understand this to be able to react and get a decision going. Then we started layering in other scenarios, assets, risks, and cybersecurity. How do you secure data and share it? That was a big deal for DoD and VA. We want to share with the world, but we also want to protect our data. If you're kind of in the middle, then it's very risky, because if somebody gets a hold of a model, for example, they have everything about the building, but if you slice it into pieces and say, here's your piece, we want you to interact with us at this level, you can actually secure data more efficiently with these new tools. Basically what Amazon's doing. They're not giving you their secrets of how they do their logistics, but they're allowing you to build your applications on top of their servers to do your thing. Blockchain. We heard a little bit about Bitcoin and blockchain, but blockchain is the underlying technology for Bitcoin. And I'm not saying this is the right thing to do, but we are exploring it. In a sandbox, it's okay to fail. So we're saying, what would it look like if you use a blockchain type technology to create agreements that are shorter, that are attached to the building and attached to the owner's requirements, that as you go through the process of design and construction, you can track everything like a ledger, ideas that are coming and tracking things that are going through that. And then we went to the National Academy of Sciences in a group of about 50 people here, and we said, okay, we presented this just like I'm doing for you today, and we said, okay, we want you to submit a requirement from your phones to the system. And from the National Academy of Sciences, we were able to work with teams there, people in the room that were not aviation experts, that were simulating, as an owner, I'm requesting these planes in these spaces. Then we had teams around the world that were experts on aviation logging in and seeing this data coming in and starting to arrange different variations of this. So the request from the audience was about a 10-minute exercise, which we actually are going to do here, so get your phones ready. And then the teams were spending an hour or 2 doing various simulations. So an hour, 2 hours, whatever, imagine 2 weeks what you can do with something like this. It's rapid data, real time, getting the expert that you want plugged into that part of the equation, asking their opinion from an engineering, from a construction, how much is this going to cost, does it fit, is it too big, too small, and getting reports out of that. So this is actually sped up a little bit. This is about a 30-minute, I think, exercise of doing one of the scenarios. But in about 5 minutes, basically, you can see kind of the logic behind it. If you had the pieces there, then you can, this is obviously not a completed design. It's the beginning of the requirement that can then be handed off to the next team to complete. And all of this is in BIM. So if you moved it into Revit or whatever, it would show up. So from the National Academies, the audience there, I was kind of surprised how many submittals we had. We actually had 2.373 million square feet from the audience in 10 minutes from their phones. This is what it looked like. Then the other teams started arranging it. This is actual building data, and this was the estimated initial cost of the building. This might be completely off, but that was kind of just a ballpark. Well, what is it going to cost tied to a database? And obviously, if you had a team that was cost estimators, they could do a lot more with that. So now it's your turn. We're going to try this. Who's up for this? Very simple exercise with your phone. It's basically an Amazon exercise, Amazon ordering. Jot this down. This is where we're going to go. Program to BIM. Either put it in your phones or write it down. The results of this, I don't have time today to show the results. I have 17.33 minutes here, but I'm going to actually present this on March 2nd online in a free webinar. So your data is going to end up in a webinar that we're going to present. Okay, is everybody ready? Okay, so what you do, we're going to go to Program to BIM. Okay, Program to BIM is a website that we created, but we're building it on top of the VA's data. So we actually moved to the side and said, oh, let's create something different on top of the VA. We're basically borrowing the VA data, the DoD data, and we have a healthcare section here. So whatever interest you have, healthcare, offices, education, transportation, each one of these is like an Amazon shopping cart. So you scroll down through here, and you say, I want a classroom, and I want this meeting room, or you could type in the name and it will start showing up. It's hitting the data in the background and pulling up. And these aren't, again, I want to stress it, these modules are not static files that are just saved on the web as templates. If the background data from VA changes and say, we no longer need one lamp here, we need 2 lamps would show up the very next minute here as we're pushing that button. Real-time data, just like Amazon's logistics, and you can go to other parts of this and say, well, I want transportation. So this one was the data that we captured from the aviation experts about the size of planes and clearances that you need, and the size of hold rooms. So just going through and select, kind of run through your head, okay, if I'm designing an office, just a simple 3 or 4 rooms, or if you can do more if you want, do multiple times. And then at the bottom, there's the next button, and that's basically your shopping cart. And you'll be sent a bill at the end of this for the price of that. It's free. This is a free tool online. It's not a definitive set of templates. It's kind of a starter kit to kind of give you a flavor of how these owners are thinking and doing things. Then you can see these numbers changing and say, well, I don't want 1 777, I want 2 of them or whatever. Or I want more hold room space. It starts changing the numbers down at the bottom, the square footage and whatever. Now imagine, this is a platform for owners saying, we want this. If you have a platform that says, here's our cost estimate for this, and you plug them together, all of a sudden you're having a dialogue directly with an owner that's saying, we're thinking of doing this. That's the pace that we're striving for here. So you put your email at the bottom, and you hit build a BIM of the selected spaces. Okay, so it's churning in the background. And what's going to happen next is it's going and hitting, oh, and I didn't put, I did put healthcare, didn't I? I think I went to the healthcare section too. The healthcare one is actually going to the VA server, grabbing what's the latest data and building the space. The aviation one's coming from another location that says, well, here's our best practices for aviation. And then if you go to your email, if you're, oh, look at that, I'm getting a lot of emails here. Okay, so somebody built, they're coming in right now, actually, from you guys. So I've set it up for today's session to actually forward to me as well so I can see what's going on for the presentation. And if you click on that, on your mobile device, it's not going to show the graphical view, but it's going to have buttons on the left where you can download an Excel file or download it. Obviously, this is heading into CAD and BIM files, so you would actually use this to build a BIM from that and use that as a starting point to start the project. And on the left, you'll notice how fresh is this BIM. We actually date stamp it, because you can go back to the link 2 weeks from now and it would be outdated. So we're putting date stamps on the data that's being sent out to you. So here it is, it's building it on the fly of these spaces. And yeah, there we go. I think my connection's not very good up here, but maybe we'll come back to that later. So you can try this later, do it several times. And what we're going to do is we're going to pull these spaces into a project, and a simulated project, obviously, and present it in a webinar in a few weeks. Okay, so let's keep moving here. Any questions about that? I ran through a lot of material. I'm sorry it's like a fire hose here, but there's a few more slides. But anything about what you just tried there? Obviously, it's a very compressed, quick thing, but any questions? Right, that's a great question. So this goes back to the complexity slide. The analysis, you can obviously limit what you're doing. And the analysis can also be, there's a lot of this can be automated. So for example, with DoD and VA, one of the analysis that they want to do is, we asked for this square footage for this room. Now what are we getting back from the architects in their BIM? There's a piece of data that can automatically check it and turn it red in the tools. So we're automating the stuff that can be automated with data. And then it's up to us to decide how much do we want to analyze. So there's never really a problem of too much data, because the systems can handle infinite amount of data. Right? Pretty much. And it's really, really much, much cheaper than it used to be. So the analysis part is up to us as an industry to be able to say, well, we want, oh, that's too many options, or this one's crazy. So we can quickly kind of wade through it, or push back and say, well, stop, that's enough, that's all I want, we're on this next path. So it's really, it's not automating the whole thing, it's really up to us to be part of that process. And that's what we found over and over again as far as patterns go. You start seeing dialogues and collaboration happening at a different pace, and stopping a project from going 2 weeks and saying, well, that was a mistake, we went for 2 weeks. It's a concept in software that's called Agile, and it's basically related to Lean and Scrum and all that. How do you start seeing things and then limit and then start making decisions from what you're seeing in front of you? Yeah, that's a big question that's always asked on all these roadmap, these agencies that we're working with. They're asking about that. How do we change contracts and requirements, and how do we work with the industry? That's obviously not going to be solved overnight. But my belief is that if we start testing these things out, we can start solving small pieces of it. There's obviously going to be huge roadblocks along the way. But blockchain, that's why we're looking at blockchain. It's actually a group of attorneys that brought blockchain to us and said, let's look at blockchain, because we're looking at it right now from a legal perspective. How can we use these types of tools to reduce the paperwork of agreements that we have to read through all this information? If we attach information to the model, for example, you can start seeing things that work or don't work. And I think that can scale. It's not solved yet, but I think it's up to us to solve, and that's what we want to explore, and the only way to really start solving it is to really explore it. Right, so I'll start with that question first. It's open, but it's still controlled. Open source doesn't mean free for all. It means you can still control it. So Amazon, going back to Amazon, they're using a lot of open source tools, but they're protecting the IP that they want to protect, and they're releasing IP that they want to. And it's up to them to dial it up or dial it down. Once they have that infrastructure in place, they can say, let's start releasing this or dial this one back. The more complex projects, I think, can be solved with this too. We're not in that space as much, but I know that if you look at other industries, I mean, Boeing, for example, and the technologies that they're using there, a plane is incredibly complex, and we're going to say, we always get this, well, what, buildings are not planes and we're not manufacturing, but it's if we take that technology and see how we can apply it. The second thing to remember is to keep things simple. A lot of the discussions out there, even in the building information modeling space, we're kind of enamored with this incredibly complex models that you fly through. Fantastic stuff, and we do it as well too. But if you start simple, you can actually start solving small problems and start building them on top of each other. And you might not know where that journey is going to take you. So when Jeff Bezos said, let's build a platform that can be externalizable to the world, he was not planning on taking over computer services for Amazon Web Services to provide that. So it's that type of small pieces, test it a little bit, and then pull back, and then fail fast and fail often, and then keep adjusting. But I would be really interested in talking to you about what you think about a more complex project. Let's move on, and I'll take questions again later. I just want to finish off a few slides. So we did this exercise. This is some of the types of results that can come from that once you start taking it into the... So your button push ends up in a model like that, literally. It's going to end up in a Revit model with the data attached to it that the VA changed this morning if they had changed it. So what's next? So The results of here are going to be presented at the BIM. If you go to BIMStorm.com, there's a red button there. If you click on that, you'll be registered for the March 2nd, 9 a.m. Pacific session. There's a lot of other information. So the question I have in our last few minutes here, we talked about platforms. We talked about finding things, counting things, and documenting things. Who else in the room has a platform? Just raise your hand. Anybody have a platform? You have a platform. Who else? Keep your hands raised. Who else has one? There, oh, there we go. Stand up. What's the name of your platform? CURT. You?
I'm with it.
You?
We have several entropy.
CURT and
Screen entropy.
Great. Yeah. Great. I have a platform that I want to connect with you guys to do things like this. Right? Imagine if I was working with Butler and we had a dental clinic and you said, well, here's how you put the wrapper around. I'm kind of making this up. I'm just guessing from what you guys do. And the same thing here with CURT. You have some kind of a life cycle software, right? Okay, thanks. Thank you very much. So let's connect later again to who else is thinking of building a platform. I know one other place. You guys. OS2 is going to be a platform. It's a platform. When it comes, it's going to connect, right? And it's going to be transformational because you have this big vision. So it's not one platform, it's many platforms because we can't solve the complexity, going back to the complexity, with a single tool or a single person or a single organization or a single piece of software. It's going to be a collection. And that's the only way this is going to work. And we can do it fast. We don't have to wait years and years and years. You can actually start solving small problems. Use open source tools that are out there, use proprietary tools that are platforms. And the platforms that I'm talking about, I'll talk a little techie here now, they need to have web services, they need to have APIs, they need to be published about how we connect to you so we can connect, right? So great, it's really exciting. I used to ask this question just a few years ago, no hands would go up because everybody's very protective. That's the other lesson here is, yes, you're going to lose some control by sharing, but you're going to gain a lot more. And this is a quote from Balfour Beatty, actually. Andreas Phelps said a few years ago, the shelf life of a good idea in today's world is 6 months. If you don't put it out there, somebody else is already doing it. So you might as well put it out there and figure out how you can use that. We've been very used to protect. Obviously, it goes back to the legal questions and everything. We want to protect our IP. We want to protect what we're doing. But if you open up, you can protect and you can create new opportunities that you can't even imagine. When I started this journey, I never thought we were going to be doing this kind of stuff. I'm an architect. Then I started seeing the value of data, and I said, well, if we get computer scientists that are also architects in my team, then you can understand computer science and architecture. And then the owners started coming to us. We're a small team. They started coming to us with these large, complex projects asking us for guidance. And we tell them, if you do it like this, there's going to be people in the industry that are not inside a burning house that can do stuff for you. That's going to create value for you as an owner and you as the contractors and vendors and et cetera. So, automate is not scary. Find, count, document. Platforms, we need to move from bad to good. Thank you very much. Questions? We have a few minutes for questions if there are any. Right, exactly. That's a great point. And yes, you can build applications on the web that are very closed. And there's a lot of them out there. And a lot of them that were closed are starting to try and open up more. There's other newer applications out there that are built from the ground up as a platform, just like Amazon did, because they see this vision. And I think that's an important distinction, because just because you're web-enabled does not make you a platform. You're absolutely correct. If you don't have an API, I mean, there's a lot of different, platform can be a lot of different things, but APIs and web services and the ability to extend and the ability for others from the outside to connect to you through, and you could still have rules, and you really are just a web-enabled application. You're a web-enabled monolith again. And that's not the future, that's the past. So I think that's an important lesson, is that in our industry, we're actually very late to the game in a lot of these technologies. They've moved a lot faster than us, So it's actually a good chance for us to look at other industries and see how that actually works and really make that happen for everybody. Any more questions? Okay. Thank you very much for your time.